Hi, I'm Hishar Veerasinghe, and let's talk about using machine learning to develop efficient heating and cooling systems. Let's move forward with energy consumption for heating and cooling. In 2019, global status reports for building and construction says heating and cooling large buildings require 30% of energy produced worldwide. While the Eurostar in 2022 says energy consumption for spaces heating in European Union household represent at almost 62.8% of total energy in 2020. Now, let's talk about why traditional heating and cooling systems are inefficient through various research findings. The researchers states that heating and air conditioning, which means HVAC systems, account for 50% of total energy budget of the buildings. Furthermore, they states that conditioning unoccupied environment will lead to significant waste in energy consumption. Now, let's talk about manipulating the system's operation through occupancy-based controls. Researchers states that we can save energy up to 20% with using occupancy-based controls. And they furthermore states that we can use machine learning in combination with a set of sensor readings to predict the occupancy. On this section, we discuss how we achieve occupancy-based controls based on machine learning algorithms. The most significant component of our proposed solution is the machine learning model. The machine learning model was developed with using a dataset which contains different set of sensor readings which we call features. These readings were collected over a period of 20 days. Now, we dive deep into the development of the machine learning model through supervised learning. We discuss how the machine learning model is developed. The most significant components of this training process is the dataset, which is contributed by Lewis and his colleagues. This dataset contains 7 number of features: the date, temperature, humidity, light, carbon dioxide value, humidity ratio, and occupancy. We use binary classification for this problem since our target group, the occupancy, has two instances, the occupancy 1 and occupancy 0, which means true and false. We use supervised learning as we have labeled data. So we have several number of phases on the feature engineering, and the phase number 5, which means determining the correlation phase. We can see high correlation between our target group and the temperature, light, and carbon dioxide. So in this training and evaluation phase, we train two models based on the features. On the model number 1, we use all the highly correlated features including our target group, the occupancy, and the model 2nd, we use all the features along with our target group, occupancy. So we are using the PyCarrot library for the training process. As our dataset is quite imbalanced, we are using the random undersampler to undersample the majority class, which means the occupancy 0 class. And with using the compare models API, we can get the highly accurate machine learning model for the model number 1 and model number 2. And we can use the confusion matrix to determine the accuracy of the model. So finally, we can say that the model number 2 is the best performing model, and therefore we can. So let's talk about the performance of a machine learning model. So in this process, we train two number of models based on binary classification, which means our occupancy has two instances, the 0 and 1. So here our target feature is occupancy, and the model number 2 outputs 99.27 of accuracy, which means it predicted 4101 correct records over 4412 records on our testing data, which means it's pretty accurate. So moving on, let's discuss the benefits of the proposed solution. As this is a machine learning model, we can continuously improve the accuracy over time based on the amount of data we collect. And again, we can bring new and more features through OTA updates, which means on the updates for this system. As an example, we can implement features such as heating or cooling the premises prior of arrival. And the most significant importance of this project or this proposed solution is we can significantly reduce heating and cooling energy which is used in large residential complexes such as the Scholars Green Students Village of University of Northampton. And again, it will bring us economical and environmental benefits. And the most important thing is the proposed solution is capable of installing on the existing systems. And that's how our solution works. So thank you all for listening.